sit down and listen, cause I'ma give you some knowledge about derivatives. First derivative of f of x gives f prime of x. Second derivative gives f double prime of x. What's next? F prime of x gives velocity. If you break derivative rules, it's an atrocity. F double prime of f gives acceleration. Learning calculus takes a lot of dedication. Derivatives give rate of change. Used in optimization problems, a wide range of questions found in FRQ packets. If you're asked to find absolute max and min, don't slack it. Plug in endpoints and critical numbers. I sit back in class and I wonder why the derivative of a constant is 0. I may not be a superhero, but I can help you figure it out. Go along the derivative definition route. Rate of change of slope is what derivative is. Know this so you can pass the quiz. Derivative of a constant is 0 because the slope stays constant, no change. This was not difficult. Just think of it logically. Sometimes we'll be asked to find derivative technologically. Now let's take a look at a derivative problem. You may recognize it because we've already solved them. Train A runs back and forth on an east-west section of railroad track. Its velocity, given in meters per minute, is a differentiable function VA of t. Time t is in minutes. Calc student, I've been it. Selected values given in the table. This video is real, it's not a fable. Part A asks to find average acceleration over the interval time 2 to 8. We're given a table with velocities. I'm sure you all feel curiosity. Don't worry, I'll explain in the next clip. I know you're confused, but please don't flip. To find average acceleration, we take derivative of velocity, v of 8 minus v of 2 all over 8 minus 2. After entering the given, we find that it equals negative 110 over 3 meters per minute squared. Part B asks us to confirm that the train's velocity could equal negative 100 meters per minute between times 5 and 8 minutes. You have to use intermediate value theorem to figure it out. Don't worry, I can show you without a doubt. Part C asks us to find position at time t equals 12. I'll teach you how, so put your books back on the shelves. You take antiderivative of velocity to give position. You take what's given and do simple addition. Part D adds another train into the story. I'm here cooking up rhymes in my laboratory. To solve, we take derivative and use Pythagorean's theorem. There are derivative rules and we must cohere them. I hope you all enjoyed my rap. Please just wait till the end to clap. My explanation video should come up ASAP. To solve this problem, we must first look at the information provided. Train A runs back and forth on an east-west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function, VA of t, where time t is measured in minutes. Selected values for VA of t are given in the table above. Part A. Find the average acceleration of train A over the interval time t equals 2 to time t equals 8. Part A asks us to find the average acceleration, so we took the rate of change of the velocity, and after plugging in the numbers provided in the chart, and after simplifying, we found that the average acceleration between times t equals 2 and time t equals 8 was negative 110 over 3 meters per minute squared. Part B. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t, with t being greater than 5 and less than 8? Give a reason for your answer. Because train A's velocity is differentiable and continuous, and because the velocity at time t equals 8 is negative 120, which is less than negative 100, and the velocity at time t equals 5 is 40, which is greater than negative 100, so negative 100 has to fall between these two numbers, between times t equals 5 and t equals 8, and by intermediate value theorem, there is a time t between times t equals 5 and t equals 8, such that VA of t equals negative 100. Part C. At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. This expression right here will give us train A's position at time t equals 12 because SA of 2 is given to us, it's 300, and then taking the antiderivative of the velocity from time t equals 2 to time t equals 12 will give us the position that it moved. And after using trapezoidal sum to approximate that it moved 450 meters west from time t equals 2 to time t equals 12, and subtracting 450 from 300, we get negative 150. So train A's position at time t equals 12 minutes is approximately 150 meters west of origin station. Part D, a second train, train B, travels north from the origin station. At time t, the velocity of train B is given by VB of t equals negative 5t squared plus 60t plus 25. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. Let x equal train A's position, let y equal train B's position, and let z equal the distance between trains A and train B. So because train A is moving east and train B is moving north, they form a right angle, and we can use Pythagorean's theorem to solve that, and z would be the hypotenuse between the 2 points. And this is what we get when we take the derivative of this equation. And after plugging in t equals 2 for the velocity of train B, which was the equation given to us, and plugging all values in, we find that the rate of change of the distance between the two trains is 160 meters per minute at time t equals 2.
Okay, so before we start for my project, I decided to do finding integrals using long division. So to start off with, since the exponent on the denominator is smaller than the exponent on the numerator, you have to use long division. So what I started doing is writing out the long division. So x cubed plus 3x squared plus 5x plus 12 divided by x squared plus 2. To divide that, you would have to square or multiply x with x squared plus 2, and that would give you x cubed plus 0 plus 2x. And you want to subtract that from the numerator. And when you subtract it, you get a remainder of 3x squared plus 3x, and you divide again, so you have to multiply it by 3. When you multiply by 3, it becomes 3x squared plus 3, actually plus 6, and when you subtract it again, you would get 3x plus 6, and 3x plus 6 would be your remainder. So from here, we would want to switch it to an integral. When we switch it to an integral, it would become x plus 3 plus the remainder divided by the denominator. So it would be 3x plus 6 divided by x squared plus 2. Okay, to start off with, we would have to separate it into 3 different integrals. So it will become the integral of x plus 3 plus the integral of 3x divided by x squared plus 2 plus the integral of 6 divided by x squared plus 2. Now for the first integral, we would want to use power rule. And after we do that, we get my big old head wasn't in the way, I'll tell you guys. We get 1/2 x squared plus 3x. The second one, we would have to use substitution. And so you would make u equal to x squared plus 2, and du equals to 2x. It's 2x dx, so you would have to divide both sides by 2. So x dx would equal 1/2 du. And you would take that and substitute it back in to the integral. And after you would do that, you would eventually end up getting 1/2 ln of x squared plus 2. And yeah. And after that, for the last thing, we will want to use... This airplane wasn't above me. Why are there helicopters at this time? I'm sorry. Yeah, we would want to use the common integral. Common integral is pretty much a principle that you use in order to, figure that out, make it simplify basically. And after this, you would want to find u and a on that integral, which a would equal to square root of 2, because when you're using this common integral, you would want to have two denominators that are squared. So 2 is pretty much the same as the square root of 2 squared. So you could just pretty much change it to that and make your a square root of 2. And pretty much you just plug in u and a to the common integral, and that would give you the last part for the integral. And our answer would end up being 1/2 x squared plus 3x plus 1/2 ln of x squared plus 2 plus 1 divided by the square root of 2 times inverse tangent of x squared divided by square root of 2. And before I forget, last step. Yep, I forgot. The plus c.
Yeah. Shouts out to Miss Chua. Shouts out to Brandon. Get it.
Nico,
Finding integrals is what I do, and soon enough you'll be able to do it too. This can only be right if you listen, and listen to what I say and think it through. Then will you be able to do what I do. First I will on division, that's the right decision. The right vision, no television, lots of multiplication. No need for a tactician to solve this equation. You simply divide the numerator by the denominator. Now hold up, put that away. Yeah, now hold up, put that away. No need to calculate it, no need for Slater. You just need your brain, a Tor, to solve this problem and get to its core. Multiply the divided by x and subtract it from the rest. Now move on to the next. Bring down the 4x squared and multiply the divided by 4. And again subtract it from the remainder. Stay with me, we'll still have to do more. Yeah. Now that we have found everything we need, let's change it back to an integral. This step is critical. The rest is easy, you just need to know a principle or two to help you understand it too. This is a common integral, you should know and make sure to keep it in store. Don't worry why, you will know what it's for. Yeah, you will know what it's for. You will know what it's for. Yeah. Yeah. Let's go back to our new integral, make sure it's divisible into 3 integrals. Power rule for the first, substitution is the next, but it's not yet the worst. Third is common integral, in which you had to store. Yes, the last step and the worst. The last step and the worst. Yes, the last step and the worst. Okay. Last step. Now simply simplify it and make sure to finish it. And leave the whole classroom lit.